Hello everyone, welcome back to my channel Study With Me. Today I'm going to explain about another example of prediction question for paper 2 standard level. Again, it is not guaranteed 100% this question will be appear in the exam, but instead you can treat these questions as a mock exam to check whether you are ready for the exam or to check what kind of topic that you're still struggling with, so you can go back and then do some revisions on that particular topic. If you find this video is helpful, please don't forget to subscribe and please let your other friend knows about my channel to support me. And now let's get started. Arsenic is an element in the same group of the periodic table as nitrogen. It is found naturally in minerals and can be produced by nuclear reactors. Part of the outer shell of a neutral arsenic atom is represented in the diagram. Complete the box and arrow diagram to show the electron configuration of the outer shell. Arsenic with the electron number 33. So the electron configuration will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d10, 4p3. So 4s would be 2 electron, 4p3, so it will be 3 unpaired electron. Explain why the electrons are arranged as shown in your answer to 1. Subshell or orbitals are filled in order of increasing energy, as 4s is lower than 4p, so we need to fill up 4s first and then 4p, and then each p orbital is half occupied because paired electron repel each other. The p electron have the same parallel spin because going up. Okay. A sample of nuclear waste was analyzed by mass spectrometry. The following mass spectrum was obtained, indicating the presence of 3 arsenic isotope. State the number of neutron in the isotope with the molecular value or MZ value of 73. As you know, arsenic. Okay, arsenic. Let me just fix it. So this is AS. Okay, so arsenic with the electron number or proton number 33, atomic number is 33, so with the mass value is 73. So to find neutron, as you know, neutron it's proton plus mass number, it's a proton plus neutron, so the mass number is 73, and we know proton is 33 because the atomic number is 33, so neutron would be 40. Calculate the relative atomic mass of arsenic in the nuclear waste sample. So the relative atomic mass would be 73 times 51 plus 8 times 74 plus 75 times 43 divided by 100, it will be 74.7. Arsenic can be extracted from its oxide by reaction with hydrochloric acid. The product of this reaction is arsenic 3 fluoride, which is AsF3. A 3D model of the AsF3 molecule is shown. Explain the shape of the AsF3 molecule. As As comes from group 5, so it has 5 valence electron. So this is 1, 2, 3, and it should have 2 electrons right here. So it will be 4 domain and 1 lone pair, as it has 1 lone pair right here. So the shape would be trigonal, pyramidal, as it has 4 domain, 1 lone pair, and 3 ASF bond. Okay, so the shape would be trigonal, pyramidal. The reaction of ASF3 vapor with fluorine gas produce another compound ASF5. The bond energy of the ASF bond in ASF3 is 445 kilojoule per mole, and the enthalpy change of the reaction is negative 436 kilojoule per mole. Using section 11 of the data booklet, calculate the average ASF bond energy in ASF5 in kilojoule per mole. So ASF3, it has 3 bond. ASF5, it has 5 ASF bond. So delta H, enthalpy change of reaction, it will be reactant minus product. So 3 ASF plus F bond F minus 5 ASF. So 3 times 445 plus FF, you can check on the data booklet section 11, which is 159 minus 5 ASF. This number is negative 436. So negative 436, it will be 1494 minus 5 ASF. So ASF would be 1930 divided by 5, which is 386 kilojoule per mole. Rutile is a titanium ore mainly consisting of titanium dioxide, TiO2. Titanium can be extracted from rutile by the following reduction oxidation process. The first reaction, titanium oxide reacts with gases chlorine and solid carbon to produce titanium chloride plus carbon monoxide, and the second reaction reacts with liquid magnesium to produce solid titanium. State the oxidizing agent in this reaction, giving a reason for your answer. So TiO2 plus 2Cl2 plus 2C produce TiCl4 plus 2CO. So this negative 4 plus 4, 0, 0, negative 4, this negative 1, this negative 2 for oxygen, yeah? So this would be plus 4, this negative 2, so plus 2. So the one that will be reduction, because oxidizing agent is reduction. So reduction would be Cl. Okay, Cl2 as the oxidation state reduce from 0 to negative 2, negative 1, yeah, negative 1. So this one negative 1, because negative 4 for Cl4, so for 1 Cl is negative 1. TiO2 and TiCl4 have the following structure. Both materials consist of metal and non-metal atoms linked by covalent bond. Explain why TiO2 is a solid, whereas TiCl4 is a gas. TiO2, as you can see the structure, it keeps linked, not like normal covalent bond for TiCl4. So TiO2 is a giant covalent structure that is linked by a continuous network of covalent bond. TiCl4 is a simple covalent structure that interact via London dispersion force, which is weaker and easy to break. The byproduct of reaction 2 is a magnesium salt. So reaction 2, TiCl4 reacts with magnesium, produce titanium. So liquid magnesium can be regenerated from the molten salt using the following electrolytic cell. State the formula of magnesium salt produced by reaction 2. So TiCl4 reacts with magnesium. So magnesium solid react with TiCl4 will produce MgCl2 and Ti solid. This will be 2, this will be 2. So it will produce MgCl2. This is the formula of the magnesium salt. Write a half equation for the reaction at the anode of the electrolytic cell. At the anode, so panic, positive anode, negative cathode. So anode oxidation, cathode reduction, and we've got MgCl2. So Mg2 plus will go right here, Cl minus will go right here. So at the anode it will be Cl, and is oxidation, losing the electron. So Cl minus losing the electron. So Cl2, here will be 2 electron and here will be 2. So this will be aqueous and then this will be gas. If a mixture of titanium and carbon is heated to a high temperature in the absence of oxygen, the following reaction occurs. Titanium solid plus carbon solid produce titanium carbon. Explain what reactions 2 and 3 reveal about the relative ease of oxidation of titanium carbonate magnesium. The answer is Ti is less oxidized than Mg because Mg reduce Ti atom of TiCl4 in reaction 2. Ti, it's more easily oxidized than carbon in reaction 3. Okay, let me explain how. The second reaction is 2Mg plus TiCl4 produce 2MgCl2 plus Ti. The third reaction, Ti plus carbon produce TiC. So this will be 0. This will be -4, -1 plus 4. -2, -1 plus 2, and this 0. So Ti, okay, Ti and Ti here, it's reduction, right? So Mg is oxidation. That's why Ti is less oxidized than Mg, because Mg reduced Ti atom of TiCl4. It's being reduced, right, for Ti. And now for Ti and C, so this Ti, it's 0, C 0, C would be -4 and Ti plus 4. So Ti oxidation, carbon reduction. That's why Ti is more easily oxidized than carbon in reaction 3. Compound X is a natural fragrance found in coffee. Its empirical formula is C5H10O. The infrared spectrum of compound X is shown. Compound X contains C single bond C and C single bond H bonds. Using the information in the spectrum and section 26 of the data booklet, deduce another type of bond present in compound X. There is C double bond O at C double bond O at 1700 to 1750 centimeter to the power -1. The HNMR spectrum of compound S is shown. This is integral, so this only for HL. Compound A is converted to compound B via catalytic hydration. This process is an example of an addition reaction. So we can start numbering 1, 2, 3, 4. Therefore, the name is but2-in. Draw the full structural formula of compound B. So when but2-in is added with water, which is OH and H, it will produce alcohol, which is butane-2-ol. So CH3, this one, and then CH, and then OH and H, and CH3. If you put OH right here, it will be the same, butane-2-ol as well, because it's 4C. Explain why this reaction is categorized as an addition reaction. Because the reaction involves more than one reactant. It means OH and H, I mean, and there is only one product, which is butane-2-ol. The conversion of compound A to compound B is a reversible reaction, means equilibrium reaction. Write an expression for this reaction's equilibrium constant Kc. So A plus H2O produce B, right? So Kc would be B divided by concentration of A and H2O. The reaction is performed at a temperature of 300 degrees Celsius and pressure of 70 times 10 to the power 5 Pascal. Calculate the total number of moles of gas per meter cube. It means volume, it's 1 meter cube of reactor volume. So PV equal to nRT. So N would be PV divided by RT. P is 70 times 10 to the power 5 divided by 8.13 times 573. This one is 573 Kelvin. This times 1, okay? Volume is 1 meter cube. If it's Pascal, it's meter cube. If it's kilopascal, this is meter cube. So that would be 1.5 times 10 to the power 3 mole. Explain how the yield of compound B changes if the pressure in the reactor is increased at the constant temperature. So the reaction is butene, but2-in, react with H2O, produce butane-2-ol. So but2-in is a gas and butane-2-ol is a liquid, and this one is a liquid. So we have 1 mole of gas on the reactant, and there is no gas or gas molecule on the product. So when the pressure increases, the equilibrium shifts to number of lower molecule of gas. Thus, the reaction or equilibrium shift to right, then increase the yield. Solid calcium carbonate reacts with hydrochloric acid according to the following reaction. Hydrochloric acid is a strong acid as opposed to chloric 1 acid HClO, which is weak acid. Explain 1 molar solution of the two acids have different electrical conductivity. Write 2 equations to support your answer. So HCl will dissociate, becomes H plus and Cl minus. So this will be fully dissociate. And for HClO, it will have equilibrium because it's partially dissociate. It will produce H plus and ClO minus, partially dissociate. Thus, HCl as a strong acid will have more mobile ions compared to HClO, as it dissociates completely, even though has the same concentration. This will cause HCl has a higher electrical conductivity. A 25-gram sample of calcium carbonate is added to 400 centimeter cube of HCl. The initial pH of the acid is 0.104. Calculate the concentration of H plus. So H plus equal to 10 to the power negative pH, which is 10 to the power negative 0.104. So that would be 0.707 mole per decimeter cube. Using your answer to be 1, show that hydrochloric acid is the limiting reactant in this reaction. So the reaction would be HCl, this is the reaction here, HCl plus CaCO3 produce CaCl2 plus CO2 plus H2O. So CaCO3, we can calculate the mole, which is 25 gram. So 25 gram divided by 100.1, which is 0.25 mole. And for HCl, it's N C times V. So C is C is 787. Okay, this is the concentration of hydrochloric acid. So 0.787 times volume, which is 400 centimeter cube, times 0.4, and that would be 0.315. Don't forget, this is here is 2. Okay, 2 HCl. So 0.315 mole per for 2 mole of HCl. For 1 mole of HCl, that would be 0.18, right? So 0.18 is smaller compared to 0.25 mole. So 0.25 mole for 1 mole of CaCO3 and 0.16 mole for 1 mole 1 HCl. So HCl is the limiting reactant. A student aims to measure the rate of reaction of dilute hydrochloric acid with calcium carbonate chips. Part of the apparatus used in this experiment is shown. So there is CO2 produced when the chips of calcium carbonate reacts in dilute hydrochloric acid. Explain how the rate of carbon dioxide formation could be measured and used to determine the initial reaction rate. you can measure the change in volume of CO2. Also, you can measure the change in pressure of CO2, or measure the change in mass of solution. The Maxwell-Boltzmann distribution for the acid reactant is shown. Raising the temperature of the acid causes the reaction rate to increase. Explain how heating the acid alters the Maxwell-Boltzmann distribution to increase the reaction rate. When the temperature increases, the another curve will be slightly to the right and then lower. So this will be higher temperature. This lower temperature. So as you can see from the graph, the peak mode moves to right towards higher energy. So larger proportion molecules have the energy the same or higher than activation energy, or EA, bigger or the same with, E, not EA, bigger or same with EA. As you can see here, larger proportion molecules that have the higher energy, and it is slightly moved to the right for the higher temperature. The peak, it's a bit lower because now we have more proportion of the reactant that have higher kinetic energy. The sample of calcium carbonate contains an reactive impurity. The students state that the impurity will alter the reaction rate per gram of calcium carbonate, and that repeating the experiment will improve the accuracy of the result. State whether the student is correct, giving reasons for your answer. The answer is incorrect. In general, an impure substance can alter the rate of reaction because in the end it contains calcium carbonate, right? But it's just impure. So in general, an impure substance can alter the rate of reaction. However, some impurities might speeding up or inhibit the reaction, or will not have effect at all. Thus, repeating the experiment will not improve the accuracy, because everything, it depends on what kind of impurities that is associated with the calcium carbonate. It could be speeding up, it could be inhibit, or it could have no effect at all. So when the students repeat the experiment, the student doesn't really know what kind of effect of the impurities from the calcium carbonate, so repeating the experiment will not give an accuracy for the experimental data. All right, so that's all for the explanation for another example of prediction question for paper 2 standard level. It is not guaranteed 100% this question will be appear on the exam, but instead you can treat these questions as a mock exam because of the questions follow the IB exam style question. So if you find this video is helpful, please don't forget to subscribe and let your other friend knows about my channel to support me. Thank you for watching, and bye.